So let's start with LangChain and LangGraph basics. So LangChain is a framework that helps developer build applications powered by large language models like GPT. So instead of calling the models directly, LangChain lets you connect the model with tools, data sources, and memory so that your AI can do more than just chat, right? So for example, with LangChain, you can make an AI agent that can search documents, call APIs, or query a database, all through a structured workflow called a chain. But here's the thing, these chains are mostly linear, one step follows another in a fixed order. And that's where the LangGraph comes in. So LangGraph is built on top of LangChain, but instead of a straight chain, it lets you design your AI workflow as a graph. So with LangGraph, your agents can plan, loop, branch, and even take decision dynamically based on what's happening during the execution. This makes it possible to build agentic systems where multiple agents can collaborate, reason, and adapt. So in simple terms, LangChain helps you build with language models. LangGraphs helps you orchestrate intelligent agent workflows. So you might be thinking, why do I need all this framework? So here are a few things that you should consider before you're building agent, right? So this help you in workflow management. So you basically organize multiple tasks, agents, and API cleanly. So it will also help you to do state management. We'll see a complete example on this. It will also help you to implement persistent memory, and you can handle all your retries and error handling in the framework. So you don't have to do anything extra to do all this, right? You also get a reusable and maintainable code. If we use this framework, we'll see like how do you create graphs using classes, objects, functions, right? And also like this helps you to create dynamic logic and branching. So you can easily implement loops, conditional paths, and agent collaboration. Now let's start with some code for LangChain. So before I show you like how to code in LangChain, so now if you go to serving endpoints in Databricks, you'll see that there are already a lot of models that is already been served by Databricks itself. So you'll see GPT OSS model, 120 billion parameter. You'll also see 20 billion. And you also see all the Llama models and also Google Gemini models, right? So you can use these models in your agentic system free from the free edition, right? So suppose you want to see how my GPT models are working, you can click on GPT models and you will see like this is getting served by a model serving endpoint. And you can use this you can use this model for your agentic system. So to do that, just click on use and it will open in Playground. So in Databricks, Playground is mostly for testing all the models that you're creating or the agents you're creating, and you can just prototype it here and you can see how your model is performing, right? To check this, you can select the model here. So right now the GPT model is selected and you can start typing here, right? So this is how you can use model here. But if you see that I'm using the GPT OSS model, right? So let me go back to the serving and let me just copy this model name, and we'll be using this same model name in LangChain, and we'll see how do I invoke this particular model in LangChain. So let me go back to the notebook. Now let's see how do I use that model with LangChain. First, you define, so we have already installed this Databricks LangChain in the requirements file, and we have used this in the serverless environment. So in Databricks LangChain, you have something called a chat Databricks. So now what you do is like you initialize the model first, and this is the endpoint that we have just copied, right? So you can give any model serving endpoint that is getting served in Databricks, and you can use that as a chat model. Once you do that, you can directly invoke this model, like you can define llm.invoke and what is Databricks. You can give any messages here. Let's invoke this. Now you see that you got the response as a content and all different types of messages you got, right? To see it clearly, let's do something else. Right now what I did was like I have imported two new things, that is human message and AI messages. Think about this, right? Whenever you're sending some message to the model. So basically you are sending it as a human message because you are asking some question to the model, so that you can wrap around human message. And whenever you get any output from your model, that is basically the AI message. So I'll wrap my messages around this two particular classes, right? So let's do that. So I'm just to store all the messages, I'm just storing it as a messages. Now basically the whatever the user message that you have, right, basically whatever the question that you want to ask your model, this is something that you are wrapping it around human messages. Similarly, you do the invoke, so you just send the message whatever you want to send it. Now you are saving all the responses, right? So whatever content that you get, right, so I'm basically doing as response.content. So whatever the result that happens after the invoke, I'm storing it as a AI message. Basically that is the AI message that you get, right? Once that is done, I'm just doing a function to print everything nicely. Basically, whenever you get any AI message, there are different categories that you get, right? Different types of messages. One could be summary part, right? So whenever the model is thinking, it will give you a summary part of it, right? And you also get a text part, right? So I'm just doing as a if else statement to just show it show it nicely on the console. So let me run this. Now you see all the messages are printed in the console. So you get a human messages like what is Databricks, this is a question you ask. You get AI messages, so it will be type as reasoning, and there will be some summary text. Summary text will be, you see that this is for what was the summary of the conversation so far. So you see the text as the user asks what is Databricks, provide an explanation, should be concise but thorough. So this summary text is being created by the model itself. Once this is done, you will get something like a type is text. In this text, your actual answer will come, right? So you see this is the actual text that you got. And this is something that is stored as a markdown. So for LLM models, everything is a text, right? To show it, suppose you want to show it properly, you can just copy this and print it as a markdown. You will see the actual output from the model. Now let's see how to use LangGraph to create a simple state graph workflow. So first, you create a class and you define is the class should inherit from a type text. So basically you are annotating this class and you are saying that from it a type text should be used as a state, and there is a graph state that is string for now. This is a very simple state that you can create for the LangGraph. Now you define different nodes and you keep state as a parameter there, and this is just a print statement for just to debug this. And you return this updated state at, basically what I'm doing is the updated dictionary I'm returning, and I'm adding whatever state that is already there, right? I'm adding a I am to at the end of that particular state. So this is nothing but to just show you in all the nodes how can you update the state, right? So this is just like a very simple way of updating the state for the particular graph. So similarly you can have different nodes. So I'm creating one more node. On the existing state, I am adding happy, right? Similarly, for this particular example, let's create this three nodes. So basically first node is adding I am, second node is adding happy, third node is adding the sad, right? Once this is done, now we'll create the graph first, right? So first create the builder with state graph, right? And state graph, I'm importing state graph from LangGraph itself, and we are adding two more state, that is start and end. I'll show you how do I use this, right? So once that's done, I'm creating state graph with the state class that we have just created. So you can pass that to create the builder, and then I'm adding the node, right? I'm adding the node name is node1, and the node whatever the function that you have just created, right? So we are giving that name here, right? Similarly for node 2, node 3, this is all good. But now, as you know, in the a graph is consists of nodes and edges, and this is where how you'll be adding the edge as well. So first, you're creating a edge first that start with start node. This is what we imported from the LangGraph, and you are adding this as a node. That means what basically you are doing, that you are having a start node, and then you are adding the node 1, then node 2. Similarly, you have node 3, and at the end you're ending with end node, right? And this is the imported stuff, right? So this is how you'll add the age. Once that age is added, you're compiling the graph with builder.compile. And this is a good way to visualize this graph, right? So we can create this as a display image and you can draw it as a mermaid png, and this is how the graph will look like. So you see you have a start, node 2, node 3, right? Let's run this first again. Okay, now this is how you'll be invoking that particular graph, right? So graph.invoke, and the initial state, if you see that what our initial state is, okay, let me remove this. What basically you are doing is you are running this graph and you're passing this as an initial state, right? So initial state will be hi, this is Anirvan. Then once it goes here, this will be initial state, and in every node you're adding something, right? So this is how this update will come. And as you see in the output, that this is the initial state, right? Then I'm adding I am happy, right? And at the node 3 I'm adding sad. So this is how the state will be updated. This is a very simple workflow to show you how these nodes and edges will be created in state LangGraph. And I hope this is clear. But as you see, this is very serial type of execution, right? Like it start from start, node 1, node 2, node 3. But any agents, whenever you'll be creating this LangGraph agent, it won't be like serial execution, right? There will be a lot of conditional statement, like if something, if you can think about flowchart, right? In you take a decision, depending upon that you either go to node 2 or go to node 3. This is where your conditional branching will come into picture. Now let's see how do you create this conditional branching. First we need to create a decision function, right? So let's define a function like decide mood, which take the state but it returns only two literals, right? That is either node 2, node 3. So this is again coming from typing as literal. So this will decide like from node 1 which node to go to, either it goes to node 2, node 3. Now let's define the logic inside this. Now I'm taking like whatever the input, that whatever the state is already there, I'm taking as a user input. Then I'm using a random function and I'm checking that we are just doing a 50 by 50 split between node 2 to 3. That means 50% of the time we return node 2 or you go to node 3, right? So this is a very simple function to create a conditional statement, and let's run this. And now we can add this decision as a age, right? How will you do that? First you add all the nodes. This is as we did it before, like you are adding all the nodes first. This is where the change will come. First it start with start to node 1, correct? So then from node 1 I'm adding a conditional edges. That means from node 1 decide the mood first. If the so 50% of the time you go to node 2 or 50% of time you go to node 3. And here, as you see that this is where the conditional edges is added, and at the end you create like node 2 it goes to end, node 3 it goes to end. But there is no like node 2 is not coming from anywhere, right? That means that depending upon your decision it will either go to node 2 or node 3. At the end you'll compile your graph and you can view your graph, but this will show you the serially. But let me execute this and let me show you how that is coming up. Now you see I'm using the same. Now you see that it has executed and it only went to node 1 and node 3. That means it skipped the node 2. That's why you're getting the output as hi, this is Anirvan, I am sad. But if I execute it again, you see it went to node 1 and node 2. That is means hi, this is Anirvan, this is the initial state. Then I am adding I am happy, right? So it goes to node 1 and node 2. So this is a very simple function to decide the mood, but you can think about very complicated workflow, right? Where you define your function that is responsible to decide your which node to go. So that's how you can define your all your nodes and edges and conditional edges. So I think this is all I wanted to share as part of this video. But what I recommend you that try with different chat models, call different chat models in Databricks, use those models, see the output, how the output differs from one model to another model. create different graphs. Like I have just created one particular conditional edges, right? You can create a very complicated graph statements using LangGraph. So try all these things and let me know if there's any issue. I'll be very happy to help you, and I'll see you in the next one.